So, somebody on Twitter, where'd he go? So this guy's talking about hardware evolution, and he says you know, there's the low-level engineers, the next-level engineers, up the chain, up the layers. He says we need to have the engineers start talking to each other, and I have plans. Shut up, Bird. God, I hate that bird. I have plans for where the hardware is going to go. What people don't realize. Okay, so basically, I don't use paging, and if you know what paging is, it means to find one address, it has to look up about 5 addresses. Okay, we're using. Shut up, bird! Smack that bird. Okay, so why? Okay, so I need all the CPU power I can get. God, I hate that bird. Okay, so I'm not using the GPU. I'm using the CPU, and there's a why am I using the CPU? Because it's in the open, and results are not the goal. We want so
okay. Did you know T-Mobile was covered? In the last year, we've doubled our LTE coverage. Our new extended range LTE now reaches twice as far and is 4 times better in buildings. Easy yourself at T-Mobile.com/coverage.
So the Intel CEO is fired. He made a slower CPU. The little I told them we were going to make monster desktops. The little made a slower CPU. He is fired. Brian Krasanich fired. Okay. Anyway,
Okay, so the CIA doesn't want computers in the hands of people because they're worried about robots and guns and stuff like that. So this is showing a CPU is just one, a GPU is like this. 7, 6, 5, 4, 3, 2, 1.
so that's the difference in a CPU and a GPU. Okay, that's Mythbusters. So what's happened today is no one wants any more RAM because 8 gig is enough. No one wants any more CPU because they're using GPU. And when the PC was first designed, it was designed to be as flexible as possible because they didn't see the future. They tried to make it flexible. And now the industry has matured, and now is the time for the next 1,000 years to redesign and make it as standard as possible. Okay, all mice need to be 2-button, 1 wheel. 2-button, 1 wheel. There's something called a USB is history. That's it's USB is evil plot by the CIA, and I'll explain why. Okay, first of all, so just to explain some of the complexity of the USB. So the USB is designed to have a network out of each port. You can actually have more than one device. They have endpoints, so they have. It's not just a single device. It's a network, and on top of that, they have a flexible language for human interface devices. Do you remember when there was an argument about how many buttons on a mouse? Okay, those days are history. Do you know what a 3-button mouse is like? A third leg that you can't put any weight on. A 3-button mouse is like a third leg you can't put any weight on. Let's say you're making AutoCAD and you want to make a critical feature on the 3rd button, but you know not everybody's going to have it, so you go, oh, we can't put anything critical on the 3rd button because most people don't have it. So if you can't rely on it, it totally all your design. It's like designing for we want to standardize all hardware. We are going to make we're going to make 2-button mice with a wheel. We are going to make I didn't find this. Hold on a second here. I just want to show you what the US So there's a report that tells how many buttons, how many. Okay. Oh, by the way, we're going to make we're going to standardize the controller. Now that is settled down, we are going to standardize the controller, and we're going to standardize the mouse. And the reason for this is because damn it, I can't find. I'm gonna hold on a second here. Why is this hard to find all of a sudden? It's just a they have a flexible report for they designed it for any number of buttons, any number of knobs, any number of. So they designed it for any number of. God, I hate that bird. Any number of. Okay, so keyboard's French. So well, just to make a point, how many pages is this? It's a lot of pages. Let me show you what the. Damn it. So when I was a kid, we made a joystick driver by peeking a port and then checking for bits for north, south, east, and west. That's as a matter of fact, the CIA wants cattle. They want you to play first-person shooters and be a dumb that is non-threatening and doesn't do anything. That's the CIA wants the whole world to be dumb cattle. That's their utopia. Dumb cattle grazing and looking around dumb, playing first-person shooters. Can you imagine first-person shooters for the next 100 years? What's going to happen? What are they going to do? Anyway, so my proposal for the mouse, the original computer had a serial port, just like RS-232, and it was a keyboard and a mouse. They had a keyboard serial port, mouse serial port. Then they switched to PS2, which I don't know why. Let me show you what a let me tell you, we are going to standardize the PC. We are going to make a super simple serial and a super simple block device interface. The reason is because white people like to program, black people don't like to program, and the fun is programming, okay? You missed the point. Did you know that the first computers were bought to have fun programming? Then it started being, and Bill Gates wants cattle. Bill Gates wants it. Bill Gates says, in the bad old days, we programmed in 6502 assembly, and we had to make sprites by hand with. Let me just show you something. The Commodore 64. This will blow your mind. It was not for okay. C64 user's manual. This is what you did with the Commodore. This is the user's manual. It's about half an inch thick, and it tells you how to program in BASIC. That's what you did with the computer, was program in BASIC. And look at this. This is the chapter on graphics, sprites. This is just the user's manual. This is what you're supposed to do. Now they call this hacking. Bill Gates says, "Oh, you're a hacker, aren't you?" That's what he would say. He would say, "Oh, binary, binary, you're a hacker." It's kind of a joke because a hack is an insult, but computer people don't understand. Hacking is for that's like operating without documentation. That's probably a sign you're reverse engineering. That's all for. So this is what you did with a computer. You entered binary numbers to make graphics, and I went ahead and just for nostalgia, you don't really program in binary numbers, but you can. Just for nostalgia, this does direct hardware access. Being read on the hardware is, Bill Gates says, abstraction layers are like condoms. You should wear at least 3, otherwise you're a terrorist. Anyway, so this is binary numbers. The VGA memory is A000, A0, A with 4 zeros. You have to set the mask register for what bit planes. Anyway, this is doing absolutely on bare metal graphics. So this is entertainment. This is what you did with a computer. The point is, well, it's entertainment. God said 640 by 480 was a covenant like circumcision. So, oh, damn it. So let me go over my demands. There's the demands are pretty reasonable, and then there's the long-term goal for the industry. These demands are very reasonable. I, Terry Davis, am High Priest of God's official temple. The TempleOS is an operating system for PC desktops that will always dual boot alongside Windows or Linux. Yeah, I'm interested in the CIA. The CIA. CIA is trying to make the desktop disappear. The CIA wants computers in the cloud. They want all computers in the cloud. They do not want, it's like taking guns. The CIA is coming for guns. They want all computers in the cloud. They do not want the citizens to have computers. They want them in the cloud. With God's authority, we are going to make supercomputer desktops. That's the goal. Monster cryogenically cooled desktops. Why do we need cryogenically? This is not done with GPU. How would you draw a triangle? Let's suppose you were going to draw a triangle. God, I hate that bird. Let's draw a triangle. Why don't we make a little program to draw a triangle? While not IP position. Let's see what this is. Okay. Well, not input pointer, that's the mouse. Well, not input pointer yield. This waits until I press a button. Then let's print out %d, %d. It's going to print the mouse position. IP. You can do it with message passage, but for kids, why would you not give? Okay, I'm going to move the mouse and press the left button. Okay, it's 175, 235. Now I'm going to press the mouse button up here. Oh, 62, 63. Okay, so it's the mouse button. We're going to, let's make 3 X1, X1, Y1, X2, Y2, X3, Y3. We're going to make a fill triangle, okay? We're going to make a fill triangle. X1 equals IP X1. We're going to draw a fill triangle. Y1 equals. Now we say okay, we have to do that. X2, Y2, X3, Y3. Now let's okay, so let's draw a circle on comma X1, Y1, comma 5, X2, Y2, comma 5, X3, Y3. So in theory, if I click the mouse button on 3 different spots, then it drew, okay, so I clicked 3 times and it drew them. Okay, so it seems to be working. Okay, now let's say, actually we can do this. Let's do it with floats. You can use integer fixed point math. Let's do it with floats. Let's go ahead and make all these floats. I just don't feel like making it complicated for you guys. Okay, now what we're going to do is okay, so for I equals, let's do 1, 2, 3. We're going to have a certain configuration for I equals y1, I lesser or equal to y2, I plus plus. Let's say my dog wants in the room. Left, right. Okay, now the left equals right equals left x, right x. Okay, left x, right x equals, let's not do it that way. Left x equals x1, y x1. We want to fill in a, now we say left slope equals rise over run. So the rise is y1 minus y3 divided by x1 minus x3. Okay, so this is the rise over the run. We want the run over the rise because that's what we're doing. Okay, now every time we step, we want gr line, comma, left x, comma y, right x, comma y, comma I. Okay, what we're going to do is we're going to step down the side of the triangle and x1 left x plus equals left slope. It's actually the inverse of the slope. Right x plus equals right slope. So this is going to draw the top half. What? Okay, I'm going to do left. There, it drew a triangle. So hold on a second. Let's clear the screen. DC fill. Win max. Win order. Clear. Auto. My dog wants in the room. Shit. Okay, so now now we go here, here, here. Okay, I didn't do it right. This is going down, but that's not going over to the other. So let's get char DC fill. So there are a lot of programmers who Why did I do that? Why do? There we go. Okay. There are a lot of programmers who cannot do this simple task of drawing a triangle. A lot of this is just algebra. So now we're going to say the bottom half, we want to go from y2 down to y3, and the new slope is let's do this. I don't know if I did. I just intuitively. No, I didn't do it right. Okay. X left slope is x. No, that's x1. It's just, left slope stays the same. Oops. Damn it. What is your malfunction? X1, X3, Y2. Oh, X2. The right slope is X3 minus X2. I think that's what we want. I don't know. I'm just guessing. There we go. So I made a triangle fill. Now, what do we do for other cases? Well, to do the other cases, you have to work it out. So we want this. We want to get rid of the stupidity so that you don't. God, I hate to Okay, so we don't want cattle. We want people to be able to do this. This is just 8th grade algebra. I did line drawing when I was in 8th grade. Here's my triangle fill. You have to do the z buffer, so you have to step through the z coordinates. I'm using God, I hate that bird. I'm using integer math. It's faster. I have 64-bit values, and I use 32 bits of fraction. And I draw a horizontal line with the separate routine. And so that's how I do my flight simulator. Believe it or not, that's 8 cores drawing triangles. 8 cores drawing triangles. Okay, so the CIA thinks they can take away our guns, take away our computers, because the GPU is where they're putting all the energy. Here's what we want to do. We want to make 7 gigahertz cryogenically cooled desktops that sell for $4,000. We're going to force 400 million people to buy them on orders from God. We want it standardized. Do you know what happens when you have a mixture of slow and fast? You have to make your video game handle the slow. So just imagine some kid is going to do a flight simulator, and his neighbor has a piece of Celeron. And so what happens? His game won't run on his neighbor's piece of Celeron. Now, why did Intel make the Celeron? Because they're evil. Anyway, why did Intel make Celerons? Because they're evil. The CIA made a slower computer. Oh, no, that fired. Brian Kucinich, you're fired. Okay, we gotta kick the out of the CIA. Anyway, they made a slower. The Intel chips they're making now are slower. They're taking away our guns. Absolutely not acceptable. We're gonna make a standard desktop that's 100% standard. It's gonna have one monitor that's 4K. That's for this. This works alongside Windows or Linux, and it's going to be 4K exclusively. No dual monitors. If you want that, you have to buy a PCI card, and you're on your own. You're kind of a loser. Anyway, God said 640 by 480 for TempleOS. That's for the white kids who like to program instead of make fonts in HTML. Anyway, so guess what? Let's say you have 24-bit color and you're a teenager and you want to make a video game. Okay, you want to make an elephant video game. So what do? You start making an elephant in your video game. You have 24-bit color. Oops, what the fuck's that? Anyway. That's supposed to be a tusk. Here's an eye. So if you have 24-bit color, it's 10 times harder to make art because you've raised the bar and now you have to do color gradients and all kinds of shit. And suddenly you lose enthusiasm for making video games because it's an order. You increased the toil. Making art is toil. And your average person who knows trig does not know art. If they know trig, okay, so somewhere is a gap. I'm looking for a flood-fill gap. Son of a... We can zoom in and go look. Control-Alt-Z zooms. Control-Alt-Z zooms. There it is. Okay, Control-Alt-Shift-Z. Okay, so we made an elephant. Good enough. Now, if this was 24-bit color, you'd be here all day. We do have two shades of gray. Control-R. Let's make it a little better. But basically, if you're a kid, you don't have time. Okay, I'm doing a bad job. So you make an elephant. Okay, so there's our elephant. So that's a sprite. You can put it on the screen and make it move around and stuff like that. Anyway, this is graphics and source code. So what we're going to do is make a standard PC. That's the first step, is to fix what we already have. This document basically tells what we need to fix. Windows and Linux and VMware need to support the Red C file system. FAT32 is blemished, and we want a simple one. As a matter of fact, we want contiguous files only. The reason for that is our files are our documents are graphics and text, and so if we look at, here's a video game for a race car game. It has graphics in the source code. If we look at the file, it has graphics in the source code. You cannot grow files, because if you added ASCII, it would overwrite the binary graphics data. These are not zip archives, they are individual files. The file system supports compression if you have .z. And anyway, so we cherry pick. We don't want to do servers. We don't want to do, what we want to do is we want to do home computers really well. And so if you say drive report, we have a RAM disk with Red C. This tells how many sectors. So let's go Control D to the file manager. Let's copy the home directory onto the B drive, which is the RAM drive. And on the RAM drive, let's go drive B directory. Let's go to the home directory on the B drive. Now if you say dir star, this is a full directory. This gives cluster numbers. As a matter of fact, I eliminated the concept of cluster and we just have blocks. We try to eliminate complexity, so we have blocks instead of clusters. We have contiguous files. We have an allocation bitmap instead of fat tables. We don't use paging. It's the same analogy. A fat table is like a page table. Now, anyway, so let's dump block 0x. So this is the directory. I went to the cluster, which is actually a block. Fixed 64-byte length. So you can only have 38 characters in a file name. Well, that's just how it goes. On here is, if you look up a directory entry, it copies in bulk these fields onto the disk. There's a 16-bit attribute, name, cluster, size, date, time. So attribute is the first two. Cluster. Well, we can modify and write. If you say true, this lets you modify and write. It's waiting for an escape. Let's modify a file name. Let's call it do it. Okay, so we just modified a file name. I hit escape to write. Now if I do directory, there should be there's a file do it. Anyway, so what we did on our Commodores was play with disk blocks. The CIA doesn't want you to know what a disk block is. They want all this stuff hidden so they can keep logs of everything you do, and you cannot know what's on your computer. But guess what? God's gonna f them up. We're gonna have all the kids are gonna be able to look at disk blocks to their heart's content. Both the Linux and other systems. That's the point. We don't want cattle. We want educated, empowered, dangerous people. We want educated, empowered, dangerous people, not cattle. We don't want cattle. What kind of whoop-de-doo world is that? Woo-woo, bunch of cattle. That's the idea. That's the utopian ideal for the CIA. Is a bunch of cattle. Woo! They'd sit there, chew their cud, and that's the utopia. Bunch of cattle. So anyway, so the NRA is for guns, the IRA is for computers. The IRA is for computers, the NRA is for guns. You. Anyway, so what are you, a terrorist? I guess so. You. So, secure boot is history. All systems need to boot TempleOS. You need a factory recall. The BIOS manufacturers have to replace. They have to provide. They have to modify TempleOS and with a driver. I'm not writing drivers. You have to make a driver. It's a temporary until we get the entire industry working with TempleOS. VMware needs to support a TAPI directly. Right now, it won't let you burn a direct CD-ROM. When you change to full screen, when you change to, the autofit this is broken on VMware. They need to fix this. You have to, every time you want to do it, you have to. So you hit Control Alt Enter, and then you can't. You have to do this every single time because they have a bug. It's probably intentional. Not only that, listen to the sound. They put distortion so that my hems don't work. They have to fix that. Why don't you make the distortion adjustable in VMware and add a reverb that's adjustable? This has gone away. I think they fixed it. The VMware used to have a bug with multi-core startup. I think they fixed it. PC speaker, too much distortion. You need to list TempleOS as an official operating system when you do an install. Okay, you need VMware plays musical chairs with the IDE for the hard drive, and here's what you need to do. The whole industry needs to put the primary hard disk on the primary IDE master, and needs to put, all systems are going to have a CD-ROM because I like them, and it's not good to have overwrite backups. You want your backups permanent and cheap. CD-ROMs, you need to put the primary CD-ROM on you need to put the CD-ROM on the secondary master. That's what you need to do. Enough of this. They made it impossible just to locate where they are. It's a bunch of primary. IDE primary is the master. IDE secondary is the CD-ROM. That's the entire industry. You. Now I'm not opposed to incomplete support. If we get one hard drive and one CD-ROM, that's an acceptable solution. I'm not going. If I have to choose between simplicity and flexibility, I'm going to choose simplicity. As a matter of fact, okay, we're going to switch to super simple. It's impossible to determine a PCI interrupt. You think I'm kidding? No, I'm not kidding. Determining what interrupt the device has is impossible because I manage to work without interrupts for the most part. I need either or keyboard or mouse. I usually get the keyboard, and I need the timer interrupt, and that's about all. I don't use interrupts for my disk access. That's why TempleOS works and nobody else's works, because compatibility, you know, it used to be the economy stupid. It's compatibility stupid. Why would you start, there's people on OS Dev that support graphics cards. Why are you going to support 1 out of 50 graphics cards? What the hell are you thinking? You can't do, and then you're going to make a backup done by hand, and you're going to do 2,000 pixels by 1,500 pixels. You can't do with that resolution without graphics acceleration. It takes me 8 cores to do 640 by 480. God said it's a covenant anyway, a covenant like circumcision. We're going to make super simple. They need to support PS2 emulated. The BIOS companies can make the keyboard and mouse work if they really want to, and there's going to be a factory recall, and they're going to have to. And if you can't do it, you have to modify and provide a driver for USB. I don't care. You f***ed it up, you got to fix it. So all I/O is going to be done with input-output ports. If you provide a secondary PCI, that's your own business. That's for Windows. I don't care about that. But we only do I/O through input-output ports, except for VGA. Normally they have a delay. We want to make the CPU operate with no delay on input outputs. They were standardized for 4 megahertz or something way back. We do our I/O with input output ports. We want to get rid of the ISA standard delay. Mom's coughing and perhaps the new interrupt descriptor table so the software interrupts are no good because they're slow. We have a Ring 0 operating system, Ring 0 only. So what we want is we want the software interrupt to be just like a call when we're in TempleOS mode. All we want is like a call. Why do we care? Because it's neato having a 2-byte call. Interrupts are 2 bytes. That's cool. We want the cool factor. The kids are going to program in assembly language and stuff like that. I don't use paging. Intel should have an option for no paging. This should be about 5 times faster because you only access 1 memory location instead of 5 every time you access a location. It takes you, Mom. It takes 5 times as many memory accesses when you have paging. Think about it. They managed to almost make it the same. Okay, all desktops are gonna have a reset switch. It's gonna boot UEFI when you power on, and when you hit the reset switch, it's gonna boot a tamper-proof ROM that has the English version of TempleOS with the King James Bible. We're going to make a new ROM every 7 years. It's going to be understood in the same way the Commodore 64 was understood. People actually got to know it. We don't want UTF. We want just 8-bit characters. We're going to have 2 fonts. One with the upper characters Russian, and the other. We want to reorganize it because we don't need the graphic symbols, except for we can move the graphic symbols up into the upper region, and then we're going to have we need to get maybe Hebrew and Greek. Try and get those fixed because it's garbage right now. Microsoft Paint and Linux GIMP need to support. I have a graphics file format. There's no simple file format. We want a lossless LZW compression that uses the same. We want to save code. We use the same LZW. Lossless is only good with 16 colors. If you have too many colors, you can't compress. And we need a different compression mode than everybody else because you, Mom. LZW is best for 16 color. So we want super simple serial. Did you know it's possible to make a device that's not hackable if you don't have if you don't have the password login? It's really easy. Let's suppose you were making a thermostat. Somebody's going to say, "Oh, it's hackable." Well, if you have just an up and a down that you respond to, it's not hackable. You, Mom. She's coughing and clearing her throat, being disgusting. Anyway, so people don't know that you can make a it's really easy to make a device that cannot be hacked. Why would you have a login when all here you just read and write bytes? Do you want to know how easy it is to make a serial port control or driver? Everybody used to learn. I had an assembly class. We did serial drivers. Fuck you, Mom. Anyway, here's the serial port driver. Basically, you just you have an interrupt when you have a byte, and then you read the byte. You read the FIFO, and it's really simple. You set the baud rate and stuff like that. We want as few baud rates as possible. We want an 819. We want USB hardware, but RS-232 software. So you see this? This is an RS-232 software. This is an RS-232 serial port driver. This is what we want, and you can make the hardware fancy and fast. We want no endpoints. We want no endpoints, no reports. We're going to standardize to. This is what the report's going to look like for all mice are going to be 2-button, 1 wheel. 2-button, 1 wheel. Little Johnny can go in here and he can look with the serial. He can just snoop on the serial line, and he can see a text packet says X plus 3, Y plus 1, wheel plus 0, left button off, right button on. So he's gonna have a packet that looks like that. He can snoop all he wants. He can snoop on his mouse he can make a he can get a microcontroller and make a driver. All he needs to do to make a driver is it's because white people like to program. There's dignity instead of being cattle. So he's gonna make you can make a driver. It's this easy. This is on my website, serial port. Anyway, so we're gonna make super simple disk with we're gonna have 5 commands for the disk. Read blocks, that's read a single block, write a single block, get drive capacity, get model, get serial number, and eject. And we're going to make the memory sticks are going to be interfaced with that. The NV memory is going to be interfaced with that. They got a really NV. Oh hell no, you. They cluster it for the new NV memory. You're going to provide a simple serial or simple block device mode. All input output is done with serial ports. We're going to make you know how you have virtual memory? We're going to make a virtual IO port layer. So IO ports are going to be renumbered. We're going to make a nice pretty consecutive. Why the when they designed when they designed, God, I hate that bird. When they designed the original hard disk, they put eight ports on primary IDE and 1 port on. They put 8 ports, 1 F0, 1, 2, 3, 4, 5, 6, 7, and then they put another port way up at 3 F6. When you're playing game, anyway, we're going to make this pretty. They're going to be consecutive, and it's going to be nice and pretty. When I was in high school, I had a book called Mapping the Commodore 64, and it told how to do direct access to all the, it told what the entire ROM did. Mapping the Commodore 64. This is what I did instead of playing games. I read about all the hardware I/O ports. That's what you did. That's what white people like to do. That's fun. Okay, they get sick of playing the CIA. The only thing that grows the brain is Minecraft, and the CIA hates Minecraft. They want to squash Minecraft, and it's pathetic compared to what we had. We lived in the Cold War when we wanted smart people. Now they want cattle. The CIA wants cattle. They don't like Minecraft because that's Bill Gates tried to kill it. He tried to buy it and kill it. Little he wants cattle. I hate that. Anyway, so where were we? So we're going to make super simple block, super simple serial. God said single audio voice. He said that's all you need. That's even worse than the Commodore 64. It's okay, that's what we want. So we want a period for a timer that goes from 20 hertz to 2000 hertz. So that's all we want, just like a word, a 16-bit frequency, good enough. That's what God wants. We do want VGA to be, we want VGA to be 1 byte per pixel, 1 byte per pixel, 1 byte per pixel, 640 by 480. Instead of the 4-bit planes, we want 1 byte per pixel. So we eventually we're gonna have a, it's not gonna be the old VGA anymore. But even though we have 1 byte per pixel, we only want 16 colors. That's just, God said 16 colors, and that's what he wants. So we want people to be able to hook up a microcontroller easily and understand what the they're doing. It's like overkill. I worked with a person who tried to put a C. He got a Rabbit microcontroller. It was an 8-bit microcontroller. He tried to do it in C. He fought with that. If he had only known assembly, it would have been a lot easier. Anyway, I don't think it's good to put Linux on a little stamp computer because that's overkill. What the so you don't know what you're doing. So we're going to make a standard Temple PC. It's going to cost $4,000. That God said to pay the national debt. He said poor people should get an allowance to help purchase it. We want it 100% standard. Now, what I observed, hold on. So, if you here's what we want the industry to optimize for. The entire industry is going to optimize for that application. So what do we want? How many cores do you think we can use? Well, you have to divide up the screen into regions to keep the cores out of each other's way. Yeah, or I divide the map into strips. I don't care if I get a glitch. So if now the cache line is 64 bytes. So if you were if two cores access the same cache line, it might glitch. So I don't really see any glitch. I don't see any glitches with eight cores. I think 16 would be okay, but once you start getting above 16 cores, I don't think it's going to look pretty. So I want 16 cores on this. This chip is going to come out in about 2 years, I figure, and we want 16 cores, not hyper-threaded, because we want them fast and as fast as possible. So we want 16 cores, not hyper-threaded. The chip should be cryogenically cooled. You need to develop the technology to make stable CPUs that are 7 gigahertz, cryogenically cooled. Now, we only need, God, I hate that bird. So, we're going to have heterogeneous cores. We only need ring 3 on core 0 for Windows applications. They only use it anyway. The other cores are going to have no ring 3, just ring 0. They're going to have no paging, they're going to have no I/O. They might have a timer interrupt, maybe a wake up interrupt, but we want to make them as fast as possible. I guess 16 cores is not really a difficult challenge, but if you get rid of paging, you should be able to make it a lot faster. And anyway, we don't need in-out ports. I was willing to sacrifice SSE MMX instructions. The SSE MMX don't do me any. The SSE MMX don't do me any good. You tell me, where can I use MMX SSE? It's not really useful. So that's for MATLAB, stuff like that. Maybe it doesn't matter. Maybe it's the other thing, God gave a tip. He said when you simulate the circuit for the CPU with all the gates and registers and buses and stuff, why don't you see where the hotspots are on the chip on a gate by gate level? Do a hotspot analysis for heat coming off of the gates, and maybe try and spread out the hot gates so that anyway, just a thought. God said that Linux wine should replace Windows. So Windows, yourselves. So we want it completely standard. So if you want an old school, we are going to get rid of USB. Because we got rid of the endpoint, it's a different hardware. We are going to get rid of the USB hardware. If you need a USB, you have to buy a PCI card that has USB support. So all devices must provide we want super simple serial, super simple block device. It's going to be done with I/O ports. You can have a PCI interface that's as as you like, but the NV memory, the SSD memory, the hard disks and everything, they're going to be interfaced with super simple block devices. Anyway, so it's going to be today we have multiple interfaces, so it's not really anything new to have multiple interfaces for the same hardware. But anyway, it requires a change to the hardware. We're getting rid of USB. So that's the plan.